Alright, so in this video, we're going to be writing polynomial functions, but this time we are going to be writing them including a leading coefficient. And we're going to be doing that through three different examples here. So let's go ahead and get started with the first one. So a function f of x has roots of -2 and 5 and is graphed to the right. It is given that f of 2 is equal to -12. What is the factored form of f of x, including a leading coefficient? So I'm going to go ahead and use the graph on my right to label my roots. So I know my first root, -2, is going to be to the left of my y-axis. So that's going to be here, a root of -2. And the one on the right is going to be then my root of 5. And so just based off of this graph, I can also determine what the multiplicities are based on how they cross or bounce on our x-axis. So at -2, it just crosses through like a straight line. So I know it's going to have a multiplicity of 1. And at 5, it bounces off of our x-axis like a quadratic. So I know that's going to have a multiplicity of 2. Lastly, we know just based off the end behavior of our graph with the right arrow going down and the left arrow going up, that we are going to have a negative leading coefficient. So using all that information, we're going to write a general equation for this polynomial. And we're going to write that like f of x is equal to, again, we know there's going to be a negative leading coefficient based off of our end behavior. So it's going to be -a. And now we're going to go ahead and write our factors. So we get our factors from our roots, and the factor for a root of -2 will be x plus 2. And again, because we have a multiplicity of 1, we can go ahead and write a power of 1, or you don't even have to write anything there. And then our second root, which is 5, will be written as x minus 5. And this one has a multiplicity of 2, so we're going to raise that factor to a power of 2. Now we're going to use the part where it says that f of 2 is equal to -12, because that gives us a point which we can reference on our polynomial. So I'm going to now set f of x equal to -12, and then have -a times, and I'm going to go ahead now and plug in this 2 in for all of my x values. So 2 plus 2 times 2 minus 5 squared. And now I'm just going to go ahead and simplify this and now solve for a. So doing that, I will go ahead and have -12 is equal to -a times 2 plus 2, which is 4. And then 2 minus 5 will give me -3, and that is going to be squared. So now I'm going to go ahead and simplify further. -12 will equal -a times 4, and then -3 squared will give me 9. And so now I'm going to multiply this negative in front of the a, the 4 and the 9 together to give me -12 is equal to -36a. And then I'm going to go ahead and divide both sides now by -36. So -12 divided by -36 is going to equal to a, which when I simplify that down, the negatives will cancel each other out. I will have 1/3 is equal to a. So I went ahead now and I found my a value. Now I'm going to go ahead and just plug that into my original function here, just to go ahead and write it all out. So my final answer will be f of x is equal to a -1/3 times x plus 2 times x minus 5 squared. And so this would be the function for all the information of this given polynomial. All right, so now let's go ahead and move on to the second question. This one is very similar to the first one. It says the function g of x is graphed to the right and has the roots of -4 and 3. We know that g of -2 is equal to -4. Then what is the factored form of g of x, including a leading coefficient? So again, I'm going to start by labeling my roots. The one on the left is going to be my -4. And this time we see that it crosses through by flattening out and wiggling through. And we can describe that as having a multiplicity of 3. And then second, we have the root on the right, which is going to be our 3. And it just crosses through linearly. So we can go ahead and say that has a multiplicity of 1. And then now we look at our end behavior. Both of our arrows are pointing upwards, so we know this is going to be an even degree positive coefficient polynomial. So this time we don't have to worry about putting a negative in front of our a when we go ahead and write our general equation. So let's go ahead and write that general equation out now, which would be g of x is going to be equal to a times our first factor of x plus 4. And again, we put x plus 4 because that's the factored form of a root of -4. And this time, again, we're going to go ahead and put our multiplicity, this time being 3. And then our second factor will be x minus 3. And we have a multiplicity of 1. And then again, just like the previous question, we're going to go ahead and plug in our -4, this time for g of x. And then we're going to plug in -2 in for our a. So -2 plus 4 cubed, and then -2 minus 3 to the power of 1. So we'll have -4 is equal to a times -2 plus 4, which is going to be 2 cubed. And then 2 minus 3 will be -5. Then we'll have -4 is equal to a times 8, because 2 cubed is 8, times -5. -5 times 8 will give me a -40, so I'll have -40a. And now I'll divide both my sides by a -40, so I'll have -4 over -40 is equal to a. And that will simplify down with our negatives canceling out to a 1 over 10 is equal to a. And then just like the previous question, I am going to go ahead now and write this all out with g of x. So g of x is going to be equal to 1 over 10 times x plus 4 to the power of 3 times x minus 3. And that will be my final answer for the second question. All right, looking at number 3 now, we don't have a graph given to us, but we do have some additional information written out. And it says that the function h of x has a double root of -2, a triple root of 2, and an end behavior of, as x approaches infinity, f of x approaches negative infinity, x approaches negative infinity, f of x approaches positive infinity. And it is also known that h of 3 is equal to -5. So what is the factored form of h of x, including a leading coefficient? So let's go ahead and write out our roots here. So a double root of -2, that means the factor is going to be x plus 2. Just going to write that below. And double root means it's going to have a multiplicity of 2. So I know that's going to be an x plus 2 squared. And then we have a triple root of 2. So this time that's going to be x minus 2. But since it's triple root, it'll be a multiplicity of 3. The last thing I want to look at really is going to be the end behavior. So it says as x approaches positive infinity, f of x approaches negative infinity, which means as we go to the right, we'll have our y values decreasing. So I know my arrow on the right will be going down. And as x approaches negative infinity, f of x approaches positive infinity. So I know when I go to the left, my arrow will be going up. So this time, based off my end behavior, I know I will have some sort of odd negative polynomial. So this time, just like the first question, I'm going to have to put a negative in front of my a value. So I'm just going to go ahead and set this up based off the information I just wrote down. So we will have h of x is going to be equal to -a. Again, we know that -a, that's going to be a -a based off of our end behavior. Then I will have my first factor, which is going to be x plus 2 squared. Again, that's from my double root of -2. And then my second factor of x minus 2 cubed. And that is from my triple root of a positive 2. And then just like the previous two questions, I'm going to go ahead and plug in these numbers. So -5 will be equal to -a times 3 plus 2 squared. times 3 minus 2 cubed. Then this will be negative 5 is equal to our negative a times 5 squared times 1 cubed. Negative 5 will now be equal to negative a times 25 times 1, which is going to be the same thing as saying negative 5 equals negative 25a when I go ahead and I multiply everything out. So then just like the last ones, I'll divide both sides by negative 25 here. And that will simplify down to give me a positive 1 over 5 is equal to a. And I plug that back into h of x to get my final equation, which will be h of x is equal to 1 over 5, or 1/5, negative times x plus 2 squared x minus 2 cubed. And so that is how we would go about finding or writing a polynomial function in factored form. When we have to go ahead and find our a value, we just have to go ahead and take an extra step working backwards and solving for a specific variable.